Hello, my name is Islam Adib and I am a PhD student at the University of Oulu, and today I'm going to present my recent paper, Conservative and Risk-Aware Offline Multi-Agent Reinforcement Learning. This research was done as part of my research visit to King's College London with Professor Osvaldo Simeoni, and this paper was accepted in IEEE Transactions on Cognitive Communications and Networking. We consider this system model where we have multiple UEVs trying to serve multiple ground sensor nodes, and the main objective is to optimize the trajectory of the UEVs and its scheduling policy in order to minimize the age of information of the sensors and their transmission power. We assume in the middle of the network that we have a risky region, where this region is considered risky because it might cause a outage in the network, or it might have some security so that the UEV should not enter this region. However, the UEV doesn't have the information about entering this region because whenever the UEV enters the region, there is only 10% of receiving very bad reward in the system, and 90% where no bad rewards are received by the UEV. So solving this problem using traditional reinforcement learning model, where the agent, which here are the UEVs, see a state of the environment, takes an action and receive a reward and transit to the new state, is not feasible because online multi-agent reinforcement learning suffers from multiple problems. First, the online interaction. It is not safe to perform online reinforcement learning in real-world scenarios because this might cause risky exploration in the environment. And it prevents the powerful reinforcement learning algorithms from being deploying in real-time applications. Second, the uncertainties. So online reinforcement learning optimizes the average performance of the agents, and it does not count for the risky actions. For example, in the previous slide, I showed that there is only 10% of receiving bad rewards from entering the risk region. The online reinforcement learning does not account for this 10%, but only account for the average performance. This causes some risky actions, such as here. If we have a heavy wind in this region, the UAV will enter the region and it does not observe the hazard from entering this region. We propose a novel offline multi-agent reinforcement learning with distributional also multi-agent reinforcement learning. First, the offline reinforcement learning part proposed to perform the training completely offline without needing any online interaction with the environment. It does so by relying on a static offline dataset collected using some behavioral policy, and it performs the optimization in a conservative way so that all actions that are out of distribution of the offline dataset are pushed close to the actions appeared in the dataset, and their weight in the optimization is very small. Second, the distributional reinforcement learning part targets the distribution over returns rather than only the average. And this enables optimizing the tail of the distributions, such as the CVAR in this figure. Here, a risk-neutral algorithm will enter the risk region, but a risk-sensitive, which is the distributional reinforcement learning algorithm, will avoid completely entering the risk region. And this is called conservative and distributional reinforcement learning approach. Here are some of the key results. We show the average test return and the achieved age of information and the transmission power. And as we can see, the proposed model outperforms other reinforcement learning techniques in both metrics. Also, it is the only algorithm which enters the risk region with a very small percentage compared to the other reinforcement learning models. Thank you for listening. If you have any question, don't hesitate to contact me via email. And also you can access the paper using this link. Thank you.